Welcome to LabMinutes.com. In this video, we'll look at how to configure a remote access IPSec VPN on a Cisco ASA firewall with a pre-shared key and certificate authentication using a software IPSec client. We also look at the NAT Transversal, IPSec over UDP, IPSec over TCP, and how their order of priority operates. So here in our lab setup, we have a IPSec software client installed on the PC. They're sitting behind a NAT device R2. They were trying to make connection to a head-end firewall ASA and to gain access to the VLAN 32. Once we can successfully make the connection, we'll go through a different scenario and test out different encapsulation types. Okay, so we can start off our configuration on a firewall 1. Since we're using an IPSec client software with a pre-shared key, we're first going to go ahead and create a user account, a local account called user with the password Cisco. Next, we're going to create a IP address pool that will be allocated to the client once has successfully connected. So the command is IP local pool. We'll call EZVPN pool with the IP range of 172.16.100.32 to 172.16.100.63, and we can also define a mask of /24. Okay, since we're going to be doing a split tunnel, we need to define a split tunnel access list. We'll call it EZVPN STACL with the standard. So you can either use an extended or standard access list here, but there's actually no need to define both source and destination IP. To keep things simple and straightforward, you can just use a standard access list and just define the subnet you want the client or allow the client to access. And that would be our VLAN 32. Okay. Now we're going to configure a group policy called EZVPN group, and this is where we can define all the parameters that will get pushed to the client. So next we'll go attribute. If you do question mark, you can see the whole lot of options that you can do. So just to make it easier, let me bring up a notepad and we can copy and paste that and keep it on the side here while we go through and configure the different options. Okay. So going from top to bottom, here we're going to first do address pool with the value of EZVPN pool that we have created. Let me kind of shrink that window. We do not have a backup server, but we can configure a banner. So a banner value, we will say authorized access only. Just do up arrow. Okay, close that out. So that would be our banner that will be presented to the user once that's connected. Next we can do a default domain, and our domain is LabMinutes.com. So when they're trying to do DNS resolution and know what or which domain name to use. Next we define DNS server value. We have a DNS server IP of 172.16.32.40. Let's see what other options that we can do here. We're going to skip the IPSec UDP for now. We will look at that later in this lab. We do not want to allow password storage because we want them to enter their credential every time they make a connection. Next we can do PFS enable. And if you want them to, let's see, Let's see the re-XAuth. Okay, so let's say we want to enable that as well. Re-XAuth enable. Okay, now we're going to define a split tunnel policy. But first, let's do the split network access list. And we have already created an access list for that called EZVPN STACL. And we are going to define a policy now. Split tunnel policy. And we want to do tunnel specify. And let's see what other options that we can do. We can restrict the access hours if you want. You can apply an access list to lock down the not just the IP address but down to the protocol UDP TCP port. We can do idle timeout. So let's do idle timeout and give it 1 hour. We can do simultaneous lock-in, and let's just say we want to do just one, and we can just lock down the tunnel protocol to just be IKEV1. Okay, so let's see what we have right now. Show run group policy. Okay, so these are the parameters that we have so far, which should be enough for now. Alright, next we're gonna create a tunnel group. Then we have a name match the group that the client will have defined on the client profile. So type is you can do LAN to LAN if you want, but here we're doing IPSec remote access. And since we are doing, let's see, next we'll do general attributes, and we'll define default group policy. We have one created called EZVPN group, and then we'll do the IPSec attributes. And here we're doing a pre-share key, so we need to define the pre-share key. Just use Cisco, and we can define ISACamp keep alive threshold of 10 seconds, and then a retry of 3. Okay. Now that we're done with the configuration of the policies, we'll get into the crypto phase 1 with IKE v1 policy 10 with authentication type pre-share key, encryption AES 256, hash with DS group 2, and lifetime 86400. Okay, now make sure the crypto ISACamp identity is set to auto. So based on the type of authentication, whether it's a pre-share key or a certificate, the firewall will determine what kind of identity, the address or host names, that it will be used to send to the client. So just leave that up to the firewall to decide. So let's do auto, which should be the default. Just want to make sure that's the case. Next we enable IKV1 on the outside interface. Okay, so that's all the configuration for phase 1. Next we do the crypto IPSec IKV1 for phase 2, the transform set called ESP AES256 SHA. So we have ESP AES256 and ESP SHA. HMAC. Okay. Next we do our dynamic crypto map called EZVPN map sequence 10, and here we have either match or set, but since it's dynamic crypto map, which we do not have anything to match, but so we're just going to go ahead and set. We have set IKv1 transform set. We're just going to copy the one that we created. Okay, next we have a set of, let's see, peer. We have no peer since we don't know what IP the client is going to be coming from, and it could be multiple connections at the time. Next we'll do PFS, and then secure reverse route. Okay, and we can also do security association with a lifetime of in second 28,800 or in kilobytes 1024,000. Okay, now that we have the dynamic crypto map, we can associate that to the crypto map called VPN map. We're going to give it the sequence that's right at the bottom, so as big as we can, so 65,000 should do it. And IPSec. Let's see. Oh, looks like I misspelled crypto. Map, VPN, map, 65,000 again. IPSec camp. Type that to dynamic EZVPN map. Okay, and then we will enable the crypto map on the outside interface. Make sure that this is also case sensitive. So has to match perfectly. Okay, now that we have the config done on the firewall, let's hop onto the client right here and make sure, first of all, that the client can ping the firewall itself and the IP is 111.11, and we can ping. So next, let's build a profile. Just going to call it the same as the group name, EZVPN group with the host IP of 111.11, group name, and the password Cisco. So save, and let's go ahead and make a connection right here. We immediately get a password, a username password prompt, and with the account that we created, Cisco and password user. Okay, looks like it's connecting us since it's saying securing connection, and here's a banner that we defined as the group policy. I'm going to go continue, and now if you do a ping 272.16.32.1, which is a switch sitting behind the firewall, we can successfully ping the switch. And if you bring up the software client interface and go to statistic, here the client has been allocated IP of 100.32. You can see a whole lot of packets being encrypted with encryption AES 256. And yes, since the client is sitting behind a NAT device, it immediately engaged the NAT. So that's why it said transparent tunneling using UDP port 4500. So this right here is the NAT transversal. To go to route details, since we have a split tunnel, the secure routes it only has 172.16.32. Okay, so that's a split tunnel. Now if you go to the head end and do a show crypto IPSec SA, you see the phase 2 connection. If you do show VPN session, remote access IKv1 IPSec, sit right here. Currently there's a user called username user is connecting with 100.32 assigned IP coming from a public IP of 222.10. So also right here said protocol is IPSec over NAT, and the group policies that's using as well as the tunnel group, the duration, how long the user has logged into or has the connection established, as well as the inactivity timer. Okay, so that's for the pre-share key authentication. So now we're gonna change the authentication type to certificate. So first let's go ahead and disconnect the connection. Alright, now we're going to make a slight modification to our config. First we need to get rid of a username, and you don't really need to, but just to show that we no longer need a username. I do no username user, so do show run username. There's nothing, and we're going to create a new crypto IKv1 policy 5 with authentication RSA SEC. So this one should take the priority over the policy 10 with the encryption of AES 256 hash group 2 lifetime 86400. Okay, now we're going to make a slight modification to the tunnel group config, and this is going to be under the IPSec attribute. First we're going to get rid of the pre-share key and replace that with a trust point that we have created already. So just to show you our trust point, show run crypto CA. Okay, so for trust point call LM root CA with enrollment URL and everything. So the firewall itself has gone through enrollment process using accept with a Windows certificate server, and it already has a certificate install. So if you do show crypto CA cert, you can see the firewall one already has a certificate assigned, as well as the trusted root CA cert. Okay, so we're going to go ahead and do IKv1 trust point LM root CA, and in addition to that we are going to disable XAuth. So we're just going to rely on the certificate authentication. So here are the commands: IKv1 user authentication none, so disable user authentication so that it will not prompt the user for the login credential. Okay, so that should be it on the head-end side. Now we're going to go ahead on the client side. We also have the certificate install. So you go view, the CN or common name is JDO, department, which is the same as OU, is EZVPN _group, and this is very important because by default the ASA will look for the OU and trying to use that to match the tunnel group. I mean, you can create a certificate map to use other attributes for your matching, but by default use the OU. So this is why we have the OU equal the tunnel group name. Then we create an EZVPN group, and the rest is just a typical attributes that you see on the certificate. Okay, so under the profile that we have created, we're going to change from group authentication to certificate authentication. And here we have a JDO certificate. So let's go ahead and make a connection. It's going through the authentication process, and here we succeeded and did not prompt for a user a login credential because we have already disabled XAuth. Okay, so now if you look at, let's try ping just to make sure it's all working, and it is. A successful ping. Statistic looks pretty much the same. Nothing's really changed. We're still doing NAT, so that's good. Go back to the firewall one with the show VPN session remote access. Okay, everything looks pretty much the same. And now if you hop to R2 to show you the NAT table on R2 with the NAT in active. Show IP NAT translation. Here we see a UDP entries with the destination IP of our 111.11 and the port UDP port 4500. Okay, so that is for NAT transversal. So anytime by default, if the client's sitting behind a NAT device, the NAT transversal will take effect. So the next thing we're going to try is to disable NAT transversal and see if it looks any different. So the command for that is no crypto ISACamp NAT transversal. So globally, we disable NAT transversal. We're going to go ahead and reinitiate our VPN connection. Looks like still going through. And we have a successful ping. And if you go to status statistic, here since NAT is disabled, the transparent tunneling is shown as inactive. Although we still get encrypt and decrypt, but if you go to R2, I guess I should have cleared the NAT table just to make it look cleaner, but here you can see an extra entries with the protocol ESP. So the Cisco router just happens to support IPSec pass-through, so instead of using whether it's the TCP or UDP port for NAT translation, it actually used an SPI. So if you go and just take remember that string of value right there, EAA, ends with EAA. Go show crypto IPSec SA. You can see that string of text actually matches the SPI of that IPSec connection. So the router, instead of using a unique TCP UDP port, it instead use a unique SPI value to make sure that there's no duplicates in the entry, and allows multiple concurrent connection of the clients to the same tunnel head-ends. Okay, so that's with NAT disable. The next thing we're going to go ahead and do is enable IPSec over UDP. So going back to our group policy configuration, right here, we saw there was an option for, let's see, IPSec UDP. So we're going to go ahead and enable that. We also are going to define the port number, and we're just going to use a 10,000, easy, a nice and easy number to remember. All right. So now that we have that configured, let's go ahead and disconnect and reconnect. So connect. Let me make sure I clear. Maybe it's a little too late now. IP NAT translation this time. There you go. Okay, now it's connected, and ping is working. Going back and check on the status. Now the transparent tunneling is showing up as active on UDP port 10,000, which is the UDP port that we defined just now. And on the NAT table, we also see 10,000 for both source and destination. So now the IPSec traffic is encapsulated inside UDP packet with 10,000. So on the firewall side, if you do show, there you go. Now instead of NAT, it said IPSec over UDP. Okay, so that is also working. Again, when do you want to use the IPSec over UDP, or to force that, or even IPSec over TCP that we'll look at just a moment? For example, if you have any kind of device, internet router, or even the ISP themselves that might be blocking an ESP packets for IPSec, then you might need to work around that by encapsulating your IPSec traffic inside a TCP or UDP packet. So this will become handy. It might not actually get anything to do with the NAT or the client being behind the NAT itself, so you might not be able to rely on the NAT to detect the NAT. It could be just as simple as an access list that somebody put on the internet router, for example, that might block ESP or even UDP. In that case, you might want to do IPSec over TCP, which we'll look at in a second here. So just to show you the priority as far as if you have both NAT enable as well as IPSec over UDP, what's going to take effect. So in Firewall, currently we have a NAT disable at this point. So let's go ahead and re-enable NAT. So just now when we have no NAT enable and the device behind the NAT, the client was using the IPSec over UDP. Okay, but now that we have NAT enable, let's see what happened. Okay, now we're connected. Ping's working. Okay, go back to statistic, and now we're back on UDP or 4500, which is NAT. So anytime you have both NAT and IPSec over UDP enable simultaneously, and the device happens to be behind a NAT device, the NAT will take precedence. But without the device, if the device is not behind the NAT device, then the client will use the IPSec over UDP that's getting pushed down as part of the group policies to the client. Okay. All right. So that's all the UDP encapsulation. Next, we're going to look at the TCP encapsulation or IPSec over UDP. And the command to enable that is actually a single line of command. So there will be a crypto ISACamp IPSec. Let's see if I get this right. Actually, it's crypto IKE v1 IPSec over TCP. And we can specify a non-default port of 20,000. By default is 10,000. So let's see if we can use 20,000. Let me go ahead and clear the NAT table on R2. And on the client side, we also need to update our profile to match the configuration on the head end. So transport by default is an IPSec over UDP. But here, if we choose to use IPSec over TCP, you have to make sure you have a matching port number. We'll click Save. Go ahead and connect. Okay, takes a couple seconds there, and now we got our banner, and we can successfully ping. Taking a quick look at our statistic, now the transport has become a TCP over port 20,000. Okay, and now on the R2, look at the NAT table. You can see a destination port is 20,000. You can see it's quite interesting to see with the UDP or IPSec over UDP, you use the same source port number as a destination port number for the first connection. Okay, but for the IPSec over TCP, you use a random source port number, but the port number that you specify in the config, which is 20,000, is the destination port number. And on the firewall side, go show VPN session RA-IKV1, and now it's become IPSec over TCP. Okay. So here you can see that if you have all NAT, UDP over IPSec over UDP, and TCP over IPSec over TCP enable all at once, it depends on what client has configured on the profile. So if the client has the profile specified to use the IPSec over TCP, that would definitely take the precedence. But if you have it IPSec over UDP checked, then it would depend on if the client's actually behind a NAT device or not, and if it does, it would use the NAT, and if it's not, it would just use the IPSec over UDP port. Okay, so hopefully that cleared things up as far as what encapsulation gets used in different scenarios. And this completes our labs on remote access IPSec VPN and the Cisco ASA firewall. Thank you for watching LabMinutes.com, and I'll see you in the next video.